Question 28, 3 marks. Iodic acid and sulfamic acid are monoprotic acids. A 0.100 moles per liter solution of iodic acid has a pH of 1.151, as does a 0.120 moles per liter solution of sulfamic acid. Show that neither iodic acid nor sulfamic acid dissociates completely in water, and determine which is the stronger acid. So the way we're going to approach this question is by noting down all the necessary evidence. So let's do that. Point number 1, both acids are monoprotic. Point number 2, we can say that if something is monoprotic without knowing the identity of the acids itself, then we can write a generic Bronsted-Lowry acid and base equation. So that's say HA aqueous plus H2O liquid gives H3O plus aqueous plus A minus aqueous. Point number 3, since both of the acids don't completely dissociate in water, we can say that both acids are classified as weak acids, because dissociation simply means that it is on the right-hand side of the equation, as the acidity is associated with the conjugate acid, which is H3O plus of the base, and then this is the conjugate base of the acid. So the more the species are on the right hand side, the more acidic the acid will be. If the species are going to spend most of its time on the left hand side, then we can say that they are not that acidic. Now the question is asking you, between the two weak acids, which one is the stronger of the two? We can look at 3 values. The most important value is the pH of 1.151. So let's explore that a bit further. We know from the theory that pH is the minus log 10, the concentration of hydronium ion. If we were to work out the concentration of the hydronium ion, it is simply this equation, 10 to the negative pH. It turns out that pH is 1.151. So let's write that out. So then H plus is equal to 10 to the negative 1.151, which works out to be 0.0706 moles per liter. So what does that mean? Let's write out more information here. It is saying that the pH for both are 1.151, a 0.0706 moles per liter of the hydronium ion, whilst for iodic acid, HA is 0.1 moles per liter, and then the sulfamic acid, HA, is 0.120 moles per liter. So then we can say that in comparison between iodic acid and sulfamic acid, iodic acid uses less concentration to make the same amount of pH as sulfamic acid, which takes 0.120 moles per liter to make the same pH. Between the two acids, iodic acid is a stronger acid using that rationale. Alternatively, we can work out the Ka value for both iodic acid and sulfamic acid and do a comparison and see which one is more right-hand side of the equation. So then let us write this out. We're going to be using the ICE method because Ka is involved. So we again write our generic equation. So that will be true for both iodic acid and sulfamic acid. Let's do iodic acid first, and we denote that as HA. So HA is 0.100 moles per liter. The concentration of H3O plus and A minus is the same because it's of a 1-to-1 ratio. Now let's set up the ice method table. So then if we go final HA is then simply 0.100 minus 0.0706. That is our answer. So let's substitute this information to Ka. Similarly, sulfamic acid can be written as such. So this one works out to be 0.169. Between these two, we can tell quite clearly that 0.169 of iodic acid is greater than the 0.101 of the sulfamic acid. Henceforth, iodic acid is the stronger acid because Ka is to the right of the equilibrium compared to sulfamic acid. Please follow and subscribe to this channel for more quality videos. I'll see you next time.